Good evening. Welcome students. Welcome all of you to Unacademy Flux. Suresh VSR talking to you today about basics of electromagnetics. So students, this is a genuine effort in helping students in understanding electromagnetics, especially those who have it for the first time in GATE, like instrumentation students or a few electrical students who are writing GATE for the first time. Don't feel electromagnetics is really tough. I want to show you that it's quite simple and easy. So welcome all of you students, joining you in the live chat. So just joining you in the live chat, waiting for all of you. This is class 6, Basics of Electromagnetics. So how are you all students? Just joining you in the live chat. Give me a second. And yeah, of course I'm live. Mukesh, hi, good evening. Vinith already joined me. So Vinith, Mukesh, good evening. Thanks for joining me. And as I announced, today's topic is Lorentz law. कल एम्पियर्स लॉ हो गया, तो आज लॉरेंस लॉ की ओर जाएंगे. Where I want to appreciate what is the greatness of Lorentz law in explaining magnetic fields. But we'll have a quick review of what we learned, all of us. Venkateshan, hi. Anant Tiwari, hi. Vikash Shah, hi. How are you all? Nice seeing you, the same regular students. That continuity is what is vital, students. Venkateshan, Vikash Shah, Mukesh, of course, ever always continuous. Vinith. That flow is vital. That's what actually I really enjoy. So students, a lot of test series are happening. Tomorrow again I'll upload in my Telegram channel all the upcoming test series. We've got fundamentals of ECE going on. We've got a lot of test series happening, students, now. So all of you stay tuned to write the test series so that you don't have to pay anywhere and go for any test series anywhere. So stay in Unacademy and do write test series. Tomorrow in Telegram channel I'll upload all the test series links again, जो already हो चुके हैं, right? So, Rice, good evening, hi. So, basics of electromagnetics, today's class is class 6, 2 more classes this week, 2 और classes हैं, night 10:30, this is my YouTube schedule. And electromagnetic waves, ये हो गया, this has been done until propagation and uploaded all the links. So, जो लोग waves तक already आ चुके हैं, those who have an idea of basics, and ECE students, you can learn waves in the Unacademy app. 8 classes, 12 hours, 1.5 hour ka 12 hours mein I've completely handled electromagnetic waves. So feel free to watch the app and watch this electromagnetic waves. Just give me a second. Yeah. ISRO previous year questions. This is also completed. And of course, this is a series going on, expecting ISRO to be releasing anytime the notification. Maybe this year if they notify. So of course, antennas and wave propagation, this is a paid course. This is also already started. 4 to 5 classes have been completed in the paid course in antennas. You can subscribe always with my code. So do feel to subscribe. Thank you, Prashant Bhargav. Thank you. Sai Varun, hi. Sai Varun is my old student. Very nice to see you, Sai Varun. And thanks for all the confidence in me. And thanks all of you for this live chat and the suggestions you are giving. We are not at a stage where we are commercially thinking now. That's what I believe in. We are at a stage where we are trying to help students through the free classes. So surely that's the response we are getting. Thanks a lot, all of you students. Thank you, Sai Varun. Thank you, Prashant. Thank you. Of course, this is in the plus category. This of course is very interesting for advanced students who feel that antennas is very tough. I want to show that it's very easy. So very lively course is going on. And of course, anytime you have doubts, you can always connect to me through Telegram, or you can subscribe with my code, or your best is download the Unacademy learning app. Follow me in this category, right? And these are all the test series we have got. See how many test series we have got. Set, Get, Go, Premier League is over, Gate of Thrones is over, Unacademy Gate Challenge is over. These are all price based also when you take it live. But now also you got chance in upcoming series. So do try them in my Super 30 test series. Then of course most expected questions, lot of things. So last class we have finished what is Ampere's law. So quick review of what we finished so far. Just look at quick revision of the topics that we have done. The quick revision of the topics that we have done was the first class I taught with what is dot product and what is cross product and what is gradient. How do you take del dot, del cross and del just on a scalar? This is the first thing that we have finished. एक scalar का rate of change, vector का rate of change and its analysis. Then we went on to understand what is field and what is electric field and what is magnetic field. Went very smooth. Students were quite happy, understanding, flowing. And the first video went for 1K. Second video also is equally going. It's still 1 day old. So it's going towards 1K. Then the third video is actually I was trying to come into the subject. That has to pick up pace. That means when I'm teaching such simplest of the simplest basics, you're enjoying it. But students, you have to come in terms to the toughness. GATE and GATE exam tests you at the top level. You cannot stay at this level alone. Don't stop your journey. GATE exam is not a 100-meter race. दौड़ के छोड़ दिए. 10 kilometer का race है वो. धीरे शुरू करो. Start slowly, but reach your destination. So after this basics, if you get the confidence in the first two videos, you at any cost have to move on to understanding of what is Gauss law. And at the same time, you should understand what is Coulomb's law. Understanding intensity and density, my third video. So understanding Gauss law, Coulomb's law, understanding intensity, density is vital to reach to that level. When I'm helping you in coming down to the basic level, you should help yourself in coming to the GATE level. So students, be always receptive to reach to the levels of understanding Gauss law and Coulomb's law. And thereafter you should understand Ampere's law and Lorentz law. If you finish off this, I promise, if you understand all these classes, I promise, you will find EMT very easy. So that a student should be receptive to reach to the tougher topics. Internet, what is happening is, YouTube, what is happening is, they're learning all easy things, all simple topics. Tough topics, nobody's learning in internet. Nobody's teaching in internet tough topics. I'll teach you, students. Because the confidence you have in me, I won't reduce it. My antennas video is just gone to 10K. Just 10K views in 8 months. Antennas topic. It's awesome. I mean, the response you gave me full josh. Because antennas में resonance से connect करके जो मैंने tough तरीके से पढ़ाया, उसको appreciate किया लोगों ने. I felt very happy. Appreciating a tough topic like antennas, connecting it to resonance, I thought I should teach the tough topics. So today, surely I'll teach you Lorentz law. So Gauss law, Coulomb's law, Ampere's law के बाद Lorentz law. And if you count exactly, there are 4 laws. And these 4 will become Maxwell's equations. Maxwell's first equation, Maxwell's second equation, Maxwell's third equation, Maxwell's fourth equation. And this will connect to Faraday's law. Lorentz law is important to understand Faraday's law. Gauss law is important to understand displacement current. That's why the sequence is very vital. That's why consistency is very vital. Yes, exactly, students. EMT is not formulas, Prashant. That's a very correct word you used. EMT is not learning formulas. It's understanding the core content of maths. So कंटेंट को समझना है कि उसमें फॉर्मूला नहीं दिखना चाहिए आपको. You should find a physical interpretation. You should find something physically linking to the 3D world. Thank you, Prashant, for that statement. Really, thanks a lot. So yes, students, what is Lorentz law now? Students, what is Lorentz law? I wanted to ask from your side. If you got any answer, you can tell me. Can anybody tell me now what is Lorentz law using your creative corner, creative brain? Anybody? What is Lorentz law? How did Lorentz law change the way you understand magnetic field? Because I rate Lorentz law. You can type it in your live chat. You can just tell me in the live chat. But let me just tell you, I rate Newton's law, Coulomb's law, and then Lorentz law. Greatest laws that govern the force equations of the world. I give full credit to it. SKS, effect will oppose the cause. No, that is Faraday's law. That is Lenz's law. SKS, आप ना Lenz's law से confuse हो रहे हैं. उसका भी नाम बहुत similar है. वो Lenz है. Effect will oppose the cause. ये Lorentz है. ये Lorentz को ऐसा लिखा होता तो ज़्यादा confusion नहीं आता था. Lorentz ko. But see the way they write Lorentz. English is a very interesting language. You can write however you want. So Lorentz law को ऐसा लिखने की वजह से you are confusing with the Lenz law. मैंने Lenz law नहीं पूछा, Lorentz law पूछा मैंने. ठीक है, अनिल, thank you. No, Lakeshwari Jaiswal, not exactly Vinith. Vinith, yes, Vinith is right. Beautiful. Vinith and Venkateshan, beautiful. Anil, hi, thank you Anil for Ampere's law. Every topic I'll teach with heart. Dil se padhate hain, so that we reach to students to the maximum. But many students come to internet and YouTube only for some entertainment, so they can't accept the seriousness. But we teach with complete heart. Venkateshan has been really Venkateshan and Vinith have been perfectly on target. Yeah, one thing is there, my videos sometimes you have to watch 2 times, because to reach to the standards of GATE you need revision, repetition, like that. My videos also you need to watch 2 times. You can pause and watch. Sometimes you have to watch it. It will be important. So Lorentz law, students, is something like this. Say, can anybody ask me what is F equal to ma? No, nobody will ask, because it is saying that mass will have a force, mass will always produce a force and acceleration, and Newton has established it that mass has got a force. Then Coulomb said that even charge will have a force if you put it in an electric field. So if you leave a mass in gravity, it will have an acceleration and a force. So mass in gravity, where gravity is acceleration, this mass will experience a force. Coulomb says, similarly charge in electric field will experience a force. Then comes Lorentz. He says that a force will equally be there on any charge provided it is moving with a velocity v. So it says that you'll always have a force when there is a charge moving with a velocity and having an entry into a magnetic field at a right angle theta. So that the force is not as simple as electric force or gravity force. The force is slightly complicated. इलेक्ट्रिक फोर्स इज सिंपल, चार्ज को इलेक्ट्रिक फील्ड में छोड़ दो तो फोर्स आएगा. मैग्नेटिक फोर्स इज नॉट दैट सिंपल. चार्ज पे फोर्स आएगा, यू विल गेट ए फोर्स ऑन ए चार्ज provided it has got a velocity, it's moving. So Lorentz told the world that magnetic field is a force on a moving charge. So that he was combining all the forces of nature and said magnetic field is also one of the force. न्यूटन आने के बाद हमें पता क्या चला कि ग्रेविटी एक फोर्स है. बिकॉज ऑन न्यूटन्स हेड एप्पल फेल. तो सर पे एप्पल गिरा तो लगा कि वो फोर्स है, तो बोला कि भाई फोर्स है. लॉरेंस के सर पे कुछ नहीं गिरा, but still they could say that magnetic field is a force of attraction. But to formulate a law बनाने के लिए उसका जिंदगी गुजर गया. His entire lifespan was spent forming a law, and the law says exactly. Rajkumar, are you talking of electric force or magnetic force? Rajkumar, your doubts are excellent. Rajkumar, all of you follow Rajkumar's live chat. They're really very good. Though they're innocent, the doubts are very appropriate, up to the point. एकदम सही doubts हैं. राजकुमार, आप एक्सेलरेशन की बात कर रहे हो तो इलेक्ट्रिक या मैग्नेटिक फोर्स की बात कर रहे हो? बिकॉज आई एम नॉट टॉकिंग अबाउट दिस. आज हम इसी के बारे में बात करेंगे, ठीक है? तो एक्सेलरेशन मैग्नेटिक में, हाँ ठीक है. राजकुमार, मैग्नेटिक फील्ड में एक्सेलरेशन आने से इट गोज टू ए डिफरेंट केस कॉल्ड एज टाइम वेरिंग फील्ड. तो अभी कांस्टेंट वेलोसिटी वाली केस ले लो. दैट इज व्हाट वी कॉल इट एज लर्निंग स्टैटिक फील्ड्स. तो अभी ना हम लोग स्टैटिक फील्ड्स पढ़ रहे हैं. वी आर लर्निंग स्टैटिक फील्ड्स. वेयर इन स्टैटिक वी एक्सपेक्ट द वेलोसिटी टू बी कांस्टेंट. So assuming a velocity to be constant, no acceleration, let's learn Lorentz law first, right? So that's the point I wanted to remember. So all of you look at the students. The unification theory is what Lorentz law is. Lorentz says magnetic field भी एक ऐसा ही force है दुनिया में जो बाकी forces जैसा है. Friction is a force, gravity is a force, masses have a force between them, charges have a force between them, then moving charge will also have a force. So that the force on any moving charge is proportional to the charge, velocity, field strength, and he did not say intensity H like ampere. Ampere ने तो field strength को H बोला था. He was not using H. He used a very new word called as B. Field strength was called as B and proportional to the entry angle, where theta is angle between velocity and the magnetic field. So this combinedly, all the four factors being influential, चारों पे डिपेंड होने की वजह से they said force is Q V cross B. Force is Q into V cross B. This is called as Lorentz law. Now please don't leave by understanding this as Lorentz law. ये Lorentz law की शुरुआत है. To physically understand it, we need to take 3 cases. That's why today's class I'll only teach Lorentz law. Even Ampere's law yesterday, I did not give a statement and leave it. I took some case studies. Similarly, Lorentz law is not to be understood as a formula F equal to Q into V cross B. नहीं. इससे B का मतलब समझ में आएगा. You'll understand what B is. you'll understand what physically Lorentz law is. Because Lorentz just gave this law. We should interpret. He gave it in 1890. After 150 years, 140 years, 120 years, 100 years, we should interpret it. So let's try to interpret it. Let's try to interpret this law. So any questions? Now please ask me any doubts. So you can ask me any doubts, but look at the summary of what I taught you. Newton said that mass produces a force when you accelerate it. Coulomb said charge produces a force if you leave an electric field. Lorentz said magnetic field is also a force. Because before Lorentz, magnetic field, nobody understood it so accurately. They used to say it comes because of Earth, North Pole to South Pole it will come. Some people said magnetic field is between bar magnets. Ampere told no, magnetic field is because of current. But he is the first person to say that magnetic field produces a force on a moving charge. Beautiful, beautiful, beautiful. Yes, Anil Kumar. Anil Kumar, exactly. I have not still taught Lorentz law. I have still not taught. Believe me, I'll teach you what is Lorentz law. Really, thank you, Anil Kumar. Yes, exactly, exactly. But you got my point, right? You got my point. The point I'm trying to teach is this, that he was the first person to say that magnetic field is not because of Earth. No doubt Earth will produce a magnetic field. That many people told. He was not talking about bar magnets. That many people talked. He was not talking that magnetic field comes because of current. That Ampere already told. He said that magnetic field is because of a charge having a velocity in a magnetic field B will produce a force. Right? So what does this mean? Have a look at it, students. Let's have a look at it once. In multiple ways we'll understand it. Look at its meaning to first of all realize what B is. Because I want to teach first of all what B is. Because yesterday I taught you what H is. I taught you how current produces magnetic field H. I want you to learn today what physically B is. For that, have a look at it, students, carefully. Have a look at the point very carefully. I hope there are no doubts now. I hope live chat, no questions so far. Right. So if you have no doubt, students, let's understand what B is. Like suppose if somebody asks me, sir, what is H? I'll say H is the cos per unit length, the current per unit length, where length is a closed length and H is nothing but the strength of the current, effect of the current, strength of the current. B is also something similar to it. F is equals Q into V cross B. If you consider a case velocity perpendicular to B, if you consider velocity is 90 degrees to B, F is Q into V into B. So that dF is, differentiate on both the sides, dQ into velocity is nothing but length per unit time, distance per unit time into B. So that dF is nothing but I dl into B. Some people call it as BAL sin theta also. But what is Lorentz law or what is B is now that it is nothing but dF per IDL. So by logic, What is B is nothing but the force on a small current element. If you put a small current element, the force produced by the magnetic field on it, short length current element, point length current element, that's what is B is. Is it not similar to E in Coulomb's law, which is force per unit charge or F by Q? So how much of force the field is producing? कितनी फोर्स प्रोड्यूस करती है फील्ड, उसे इलेक्ट्रिक फील्ड में E बोलते हैं, तो मैग्नेटिक फील्ड में B is what we say. Any questions, anybody, students? Any doubts? Look at the mathematics steps carefully. You should be convinced with the steps. Otherwise, there's no meaning in the maths. Look at the mathematical steps. This is a very vital thing. 90 degrees. Take time. If you got any questions, ask me. This is one interpretation of Lorentz law. There are lot of such interpretations you can go for now. एक interpretation से नहीं हो गया. There are a lot of interpretations. Most vital. Lorentz ने B जैसी word मजाक के लिए use नहीं किया. He meant what B is. He introduced the word what density B is. Rajkumar, you are my perfect student, Rajkumar. You make beautiful student. What is the direction of B? Just give me time. Beautiful question. Beautiful. I think, let me define B यार. B का definition तो होने दो. तो I'll give you the direction of B. Force किस तरफ आएगा वो देखते हैं. Beautiful question. Anything else? I think Rajkumar, both of your questions today are beautiful and I could not answer both. I need some time for both because you did basics ना. Really good doubt, Rajkumar. अभी B का direction के लिए थोड़ी time है. But any other doubts? Otherwise, I'll define what B is. I want to define what B is. What is B, students? If you have a current wire I of a DL length, I of a very short length, point barabar short length current wire. This, if you place it in magnetic field perpendicular to it, you place it in a magnetic field exactly perpendicular to it, like this. So if there is any magnetic field and if you place a current wire perpendicular to it, the force acting on it is B. The force acting per a small current element. So that B acts only when the current is non-zero, or the wire is non-zero, small current element. So that B has the units of Newton per ampere into meter. It is the force acting on a small perpendicular current element. Because you following? Because Vinith, Bikasha, Mukesh, Rajkumar, all of you, I know your sincerity and level of sincerity, recognition, and I know how closely you are monitoring this. Anil Kumar, feel free to ask me doubts, feel free to repeat. So Lorentz told that magnetic field is also a force of nature. He was very clear that magnetic field is one of the forces of nature, which is a force acting on a current element. And current is nothing but moving charge. So that he was linking to Ampere's law. Because Ampere told that current produces magnetic field. He said, yes, current produces magnetic field, which is in turn a force. जो एक और force है. Absolutely. Torque तक, Anil Kumar, this topic is really linked to torque. Torque तक इसको link कर सकते हैं. सही है. So current अगर magnetic field produce करती है, Ampere's law. So what is Ampere's law? Stopped very early. बहुत basic है Ampere's law कि current हमेशा magnetic field produce करती है. But what is Lorentz law is? He says that magnetic field is something that will create a force on this current. करंट की वजह से जो मैग्नेटिक फील्ड प्रोड्यूस हुआ वो कुछ नहीं है, एक और फोर्स है. ए फोर्स which is going to affect your current wires. So therefore, if you have a stator in some motor, if you have a winding in a motor, एक स्टेशनरी वाइंडिंग है मोटर में, this winding in the motor will produce magnetic field. And what will that produced magnetic field produce? It will cause moving of the rotor. This is Lorentz law. So whenever you have a magnetic field produced from a current, that magnetic field will again produce a force on another current. It will produce force on one more current. That force produces B. That if you understand this point, students, B is a force measure called as density, which has got the units of Weber per meter square, which has got the units of Tesla, and everybody understands force is BAL sin theta, but we don't give credit to Lorentz law. We should give credit to Lorentz law that B is density, Weber per meter square and Tesla, but B actually means Newton per ampere into meter. This is also technically correct. That's why we say F is equal to BIL sin theta. Any doubts, anybody, students? This is one interpretation of Lorentz law. So I defined ultimately B as something like this: force acting on a small perpendicular current element defines B. Interestingly, B or H जो भी कहिए, they are related to each other as mu, permeability, material's ability to produce a magnetic field. So how much of current will produce how much of magnetic effects purely depends on the material property Henry per meter, permeability. So therefore, the force produced depends on the current and the material property. Rajkumar, I hope you understand what is the direction of B. I hope you understand what is the direction of B now. The direction of B is the same as H. B and H have the same direction, which is around the current wire. So magnetic field produced around the current wire will produce a force. That extra point is what Lorentz told. So therefore, magnetic field is a force at same direction as the H, which is around the current. I hope you got the point. I hope you got the point, Rajkumar. You should not understand that B is a different thing. B is the same as H itself. But B has got a different units, different notation. Where H is nothing but the magnetic field expressed in terms of the cross current. B is nothing but magnetic field expressed in terms of the force. This is exactly similar to D equal to epsilon E. This is exactly the same as D equal to epsilon into E, where D is a measure of strength in terms of the charge, E is a measure of strength in terms of the force. I hope you got the point, students. Any questions? Take 10 seconds. If you got any doubts, ask me. Magotra family. Yeah, exactly. Newton, Coulomb, a lot of scientists, a lot of students will be like that. So you remember my class and jokes always, Magotra family. So nice seeing you in the live chat. Hi. So I hope you understand, students, strength always can be expressed as density and intensity, whether you believe Coulomb or Lorentz or Ampere or Gauss. So this idea is so clearly Ampere's idea. This idea is clearly Coulomb's idea. This idea is clearly Gauss' idea. This idea is clearly Lorentz idea, which will be combinedly called as Maxwell's equations later on. Though with slight modifications, this becomes your Maxwell's equations. I hope you got the point. Take 10 seconds. Any doubts you can ask me. I've got one more interpretation for B. I did not finish teaching Lorentz law still. एक और interpretation है B का. Still we can understand B in a much different way. Different way also, see, very interestingly different way also. Right? Any other doubts? Any other questions? Great people in the 18th century concluded that field is a force. They were Europeans. We should give credit to Europeans. They were French and German and all British Europeans who were telling that invisible forces act in the nature. Invisible fields will produce invisible forces. And they were coming with well-defined maths for that. Somebody came out with one type of maths, writing integration maths. Some other person has come out with differentiation maths. So for three-dimensional fields, they are writing different mathematical rules, which Maxwell has excellently summarized. Made the subject interesting. He made it really interesting. Oh, Magotra family. Oh, nice, really nice. I know students who are serious will certainly settle down in life. I know Magotra family really thanks a lot for the confidence. But just maintain some seriousness, at least with the subject and learning. You will very well settle in life. Don't believe this negative people. ECE में कुछ नहीं रखा है, GATE में कुछ नहीं रखा है, उस में कुछ नहीं है, इसमें कुछ, वो सब negativeness है. The fact is different, that we need quality people and quality is missing. Why are the GATE qualifying marks only 28 out of 100? 28 marks out of 100 if you are not able to get it. So that's where quality is missing. It's not that chance nahi hai, quality is missing. So Magotra family, nice to see you in RRB, settled very well. Thank you, thanks a lot. Thank you, thanks for the confidence. Thank you. Right, let's continue this discussion now, students. इसको discussion को आगे बढ़ते हैं. To understand Lorentz law in a different way of a moving charge example itself. Let's look at this understanding once again. Rajkumar, you will really enjoy it. Rajkumar will really enjoy this. And of course, Anil, you'll also really enjoy it. How you understand Lorentz law apart from force on a current. So the summary of this discussion is that F equal to Q into V cross B is helpful to understand and define B. It has actually defined what B is. It opened to the world that magnetic field is a force. Force on a current element. That's what it opened to the world. It was not saying that magnetic field is only between bar magnets, it will attract, repel. Everybody knows that, know that gravity will attract. But Newton told F equal to ma. Everybody knows that magnetic force will attract. But Lorentz told F equal to Q into V cross B. So given this F equal to Q into V cross B, understand it in a slightly interesting way. You look at this equation carefully with a velocity in the x direction. Consider a charge in the x direction. Consider a B in the z direction. So that x cross z, because this is cross product, will give you negative y because the sequence is xyz. So x cross z will give you negative y, means you will get a force in the negative y. This can also be used for interpretation. ये भी interpretation के लिए बहुत ही important है कि whenever a charge enters in x direction in a field in z direction, you get a force in negative y. Look at its meaning. Look at its meaning now. The meaning of the discussion is, if there is a magnetic field out of the board, like this, out of the screen, with this being x-axis, this being y-axis, let z be out of the screen. So consider a charge moving like this. Consider a Q moving with x velocity, with the B already in the z direction. What is the force it is going to act? The force you can expect is in the negative y. So if you look at this V Kiran, when you started by saying Telugu, half the respect you lost. Because when I'm teaching seriously, you ask me something Telugu, you lose some respect. When you ask a genuine doubt also, I can't get respect on you. That's where the seriousness of the class is. You understand it? That's where your behavior is important. So V Kiran, dislike my video and go, but please don't disturb us. मेरे को dislikes मार दो, कितने भी मार दो, I don't mind, because I know who likes me. But seriousness is important. You got the point, V Kiran? Yeah. Anil Kumar, actually you can relate to power systems also EMT. It's very easy, Anil Kumar. Machines ko hi nahi. It's very easy to relate to power systems. Wherever necessary, if you're from electrical, inform me. I'll surely link it to your required subject also. Surely I can link it. But यहाँ पे ध्यान से देखो, it's too basic ना, अभी बहुत fundamental है ना. So charge is coming horizontally, force is dragging it down. So where does the charge move now? The charge will now move, certainly not forward. It will move in between like this. Because something is pulling it down, it is trying to move forward, so it will pull it down like this. But since the expression is force is equal to Q into V cross B, the force will be again perpendicular to it, still perpendicular to it. Because force is always perpendicular to velocity and B. So on it continues. So that's where the point is that the resultant is now going to be like this. And again perpendicular to it. So red pen is the resultant path, yellow pen is the force. Can you tell me what is the resultant path now? You are having a repeated force, you are having a velocity. What is the resultant path? The path is excellently, if you smoothly join it, it's a circular path. It's excellent to notice that it is a circular path. So what Lorentz told is, any moving charge perpendicular to it will go in a circular path. That is justifying Ampere and all the older experiments. Beautiful, beautiful rule. That's where Lorentz law is. And you have to focus for it. You have to really focus for it. You have to really focus on it now. That is the meaning of cross product. F is equal to Q into V cross B. Force that you get is perpendicular to velocity and B. Rajkumar, that's what cross product means. The resultant of these two operations will be perpendicular to the both operations. The resultant force will be perpendicular to V and B. Rajkumar, I hope you got the point. Venkateshan, super. Anil Kumar, perfect. Prashant, not exactly projectile motion, but still you can connect it. Not exactly projectile motion, that's parabolic. This is a continuous circular path. Still, we have got a very interesting way of putting it. Still it's not over. Don't think that the topic is not over. It's not over. It's still there. It's still lively. But you almost got it. Anil Kumar is perfectly clear. Venkateshan is almost clear. Prashant, of course, coming on track slowly. And Kiran, perfectly coming on track now. Kiran, that's exactly the point. The point I'm trying to teach, Kiran, is force that you have when it is perpendicular. Rajkumar, listen to it. The force that you're having when it is perpendicular to velocity, remember that velocity means displacement, because velocity is parallel to displacement. So the resultant is that force will be perpendicular to displacement. So that what is force dot displacement? Force dot displacement is force into d into cos theta, which is work. Work becomes 0. Work becoming 0 means charge will only take circular path. Charge cannot take straight line acceleration. Energy change and all won't be there. All this is the explanation of Lorentz law. But everything is based on your understanding of cross product. Lorentz ने मजाक के लिए he did not say that F is QVB sin theta, नहीं बोला उसने. He did not say like that. He said F is Q into V cross B. We don't give importance to cross. Lorentz ने Q into V dot B नहीं बोला है. V dot B नहीं बोला है. Dot नहीं बोला वहां पे. Neither he just multiplied QVB. No. He very clearly said cross. Because he was clear that the force is perpendicular to velocity. Perpendicular to B. Rajkumar, again you are asking me the same doubt. I am answering the same thing from the beginning. You are not still understanding cross product. Rajkumar, cross product पे ध्यान दो. Take 10 seconds gap and ask me questions now still. Rajkumar, force and velocity is perpendicular because cross product है Lorentz law. It's not multiplication. Cross product है. Kiran, I hope you're understanding it. Magnetic field is a circular force around the current wire. That Ampere knew it. But equations नहीं था उसके पास. Lorentz had the perfect equations. You know, I'll tell you a small example. I think I'll tell you a small real life situation. Students, 2 seconds I'll deviate. 5 seconds I'll deviate. I'll just come back. You know, there was a current wire. Some experiment was going on by Oysted. वो भी यूरोपियन था. Oysted. कुछ experiment के लिए current wire था वहां पे. He was sending some electrons and doing some current with battery. इतने में कोई आके they left a compass there. Compass needle. वो compass होती है ना जो छोटी सी small, what do you call it as compass or small magnet. This current was affecting this compass and it was reflecting. उसका direction बदल रहा था. They found interesting. Compass should show direction in earth magnetic field. They found it showing near current wire. So they started to see the compass direction gradually. They found that the compass direction is showing in a circular path. The compass was ultimately showing a circular path. Then Ampere came with the law. Magnetic field is a circular force around the current because compass was showing like that. Yeah. Izaz, Hashmi, hi. Izaz, you're the same one. Yeah. Aditya Narayan. Helical path is when you have inclined field. Helical path is when it's inclined field. It's a different case. I think you'll have to wait for it. Maybe in Lorentz law we can't cover it. Aditya Narayan, we can't cover it in Lorentz law. But nice, really nice to really. I mean, it's slightly beyond your basics. I don't think today I can cover it, helical path. It will deviate. Because I took perpendicular case now. So this is the summary of what I am trying to teach students. The summary of the discussion is, when you have a magnetic field and let a moving charge or a current be there, moving charge or current, there will be a circular force on it. So that magnetic field is a circular force. So the common sense is this. Bhuvanesh, don't link up electromagnetic. Bhuvanesh, don't link up electromagnetic field still until you learn Maxwell's equations. So you should always see, you can link up potential energy and kinetic energy. No doubt, they're interchangeable, they are convertible, but still not now. Always understand that electric field is because of a static charge, stationary charge. Magnetic field is because of a moving charge. Keep your brain like that. Bhuvanesh, doubt is good, really good. Magnetic field, you keep it independent as a effect of a moving charge, like kinetic energy. Potential energy, electric field, static charge, keep it aside. Don't mix up both. But good doubt, good, really good doubt. Really good doubt. Aditya Narayan, I don't think in the basics we can really discuss about it, but maybe when we come to some advanced topics, or you can search for my videos in app about magnetic forces. I've done a free class on magnetic forces, 1.5 hour class, I think 2 hours class, only on magnetic forces. In that you can understand helical path. It's a special case, I've covered it. So watch it in the app, you'll get the details, or you can send me the link, I'll send you the link. So if you're clear with the discussion, students, what I taught you today is this. The summary of what I taught today is, all of you listen here, that interpretation of F equal to Q into V cross B says two things. It says two vital things. First thing is that moving charge entering a magnetic field, moving charge entering a magnetic field, moving charge entering a magnetic field takes a circular path, and it is not me who is speaking this. It's not me who is speaking this, it's Lorentz law. So that's where the first logic is important. That the logic I want you to understand is, moving charge takes a circular path and linear charge takes a straight line path in electric fields. If you leave a stone in gravity, it won't dance and go. It will go straight. So Aditya Narayan, your doubt is exactly the same. Aditya Narayan, you are not able to distinguish between kinetic energy and potential energy. You are mixing up your brain. So Aditya Narayan, this is the first point, very vital, crucial. Leave a stone in gravity, it goes in straight line path. But leave a paper in water, that too in washing machine, leave a paper in washing machine, it will take a circular path. That clarity is important, man. You're mixing up so many things, Aditya Narayan. This is the first interpretation. And please don't necessarily mix up with this interpretation. F equal to QE. Charge in an electric field produces a linear path. Moving charge in a magnetic field takes a circular path. Any doubts, anybody, students? Actually, Anil, every day you have to take the notes. In my app classes, every student will be every day taking a notes and writing it. It's very vital. I mean, we go in a sequence now. So in fact, in the live chat, they don't really get time to respond because they'll be busily writing. So in fact, it's mandatory rule in my app classes that they should get the notes and keep systematically noting it down. It's very vital. You can watch it and prepare it also again. Now, if you continue this discussion, students, the second interpretation is B refers to the force or strength of the magnetic field refers to the force or strength of the magnetic field acting on a current element. How much of force a current element will feel perpendicular to the field if the current element is perpendicular to the field? All these points makes up Lorentz law. And all, don't go to all beyond advanced things. It's basics. Relax, Rajkumar, relax. Stay on to the basics. Right? And Kiran, don't go to torque and all still. We're not want to torque and all, yaar. We're not come to the torque and rotatory forces. Chill, Kiran, chill. We're at Lorentz law. And even Aditya Narayan, don't mix up advanced things. We are not even finished 6 to 7 classes. Just relax. So the common sense I want you to understand is don't mix up torque on the day of learning force. But my app contains a 2 hours class where I've related from force to electric and magnetic torques. You can watch it in my app. I mean, it's a free class which I took it in Unacademy app. Do surely watch it. There it will contain in a sequence. But it's a 2 hour class only on magnetic forces. That too for advanced people who have finished 25 classes. After 25 classes, you start understanding what torque is, how Lorentz force can be interpreted. Don't relax, just relax. So any such things, please watch my special classes, and any such things, please come to the app and watch it, but come in a sequence. So this is the summary of understanding Lorentz law, students. Any doubts, anybody? Any questions? 2-point summary, Lorentz law. So that I can now tell you that I finished 4 topics. I can tell you that I finished 4 vital topics. So that tomorrow's class, we'll again understand intensity and density, relating this to potential, not to torque still, relating to potential. How the density at a point and intensity at a point physically give you the energy calculations there. Very vital for exams, very interesting point. So that's for today's class. Any doubts, anybody, stay back. Those who have no doubts, you can log out. Those who got doubts, stay back. Right? Yeah, SKS, if V is not constant, it becomes an accelerating charge. I told it in the starting of the class. If V is not a constant, it is accelerating charge. It is not static fields. It comes in time varying fields. So when V is constant, this is what we say DC current. This is what we say static fields. It becomes time varying fields now. So that needs to understand with Maxwell's equations. We're at static level. Right? Thank you students. Those who have no doubts, you can log out. Those who have got doubts, stay back. Because generally this is my approach in the app class also. After 2 hours class, those who don't have any doubts, you can log out. Those who have doubts, stay back. And if the doubts are concerned with this, we can discuss. If they're too high and too mixing up, I don't think we have to discuss today. You concern with Lorentz law, stick on to it. Stick on to some Ohm's law, or stick on to some Gauss law, stick on to some simple rules. I can certainly discuss about today's class. So any doubts about today's class? Yeah, thank you Bonesh, thank you. Thanks all of you students. Chaitanya, good evening. Rajkumar, any doubts about today's class? Rajkumar, any doubts, anything? So can I log out? I'll wait for 10 seconds because there may be a delay of 10 seconds. So if you got any doubts, you can tell me, otherwise I'll log out. Thank you Venkateshan. Bye Rajkumar. Mukesh, bye. Thank you.